Hello students. In the previous class, in the previous video, we have seen what we have done. Just let me open that. Yeah. In the previous video, as I told you, 2.1a is going to be one key, but we tried with two keys, right? If you start the simulation and you know that it works. Now, in 2.1b, please take a screenshot of this and save it. And you're not going to use this circuit to build the rest of the 5 or rest of the 6. No, I don't want you to do that. I want you to create a new circuit. Name it as, do not forget to name it 2.1b 7 keys mini piano underscore 7 keys mini piano underscore your name underscore grade, whichever grade you are in, 7 or 8. So we are going to start the same thing what we have done it before. Have the Arduino, have the keyboard, breadboard, piezo, have the piezo, make sure that it is rotated and connected at the bottom, have ground. I'm gonna go really fast for the first steps because we already done that. In case if you need additional help, I would ask you to pause the video, continue the steps, and then get back to the video and then redo it and follow with me. Ground, and you know that 5 volts must be in red color. You need a resistor, rotate it, make sure that it is 1 kilo ohm, and connect it to the negative terminal, to the resistor, to the ground. And the positive terminal, I remember telling you guys to change it to pink, and take the cable from pink, go down, connect it to digital pin 2. Now the buzzer receives the signal, which means you can send the signal by pressing any push button. So the first thing that you need to do is get another push button. What I'm going to do is I'm going to get all the 7 push buttons at once. 1, 2, 3, 4, 5, 6, 7. In case if you want one more, you can take one more, but let us start with 7. And the 1A is a positive terminal. That means it goes to the 5 volts because every push button needs 5 volts for it to function. So I'm taking the 5 volts from the positive part of the breadboard and connecting it to the push buttons. So far I did 4, 5, 6. Make sure, the common mistake is students think they are connecting it to the positive one of the LED, but you see you are connected over here. This is a common mistake. Make sure to connect, must be like this, right? Again, I did a mistake over here, which was connected to the negative terminal, and that means this button is not going to work, and it should look something like this. Okay, now I told you we would need resistors to connect from the ground to the terminal 2A of each push button. So we have 7 push buttons, that means we need 7 resistors. Please connect all the 7 resistors. Okay. Once you connect all of these 7 resistors, each push button, I did forget over here. Each push button must be able to read the signal. I mean, Arduino must be able to read the signal from each push button. So for that, you take cables from, change it to green, 3 to over here, and then 4 to over here, 5 to over here, 6 to over here, 7 to over here, 8 to over here, and 9 over here. If you have to use one more or two more, connect it to 10 and 11. Okay, but for now, let us start with this. This looks a little funny. Let me see what can be done. Okay, I'm gonna pull it a little down. Yeah. All right. Now, if you zoom out, your circuit is done. Very simple. What you have done in the previous project, 2.1a, is one button, but now you have 7 buttons. Okay, and make sure that all the 7 buttons are connected over here. And now, pause the video if you need more time, and then complete that, and then get back to the code part. Your circuit should look something like this. Okay, your circuit is done. Now delete the code, play speaker. This is always going to be pin number 2. Okay, and how many times do we need? We need this almost 7 times, but let us do, oh, we do have a duplicate. Okay, so when you right click it, we get the duplicate sign. Okay, so just when you click duplicate, it duplicates. So let me do this. Control repeat while, go to the math part, comparator. The first one is digital pin 9. Let's start from the top now. Digital pin 9, right? So what happens is, go to input, read digital pin 9, not analog pin. We are not using any analogs. Analogs are over here. We are not using any analogs. We are using only digital pins. Read digital pin 9. Now let us duplicate. Oh, my bad. Oh, hold on, guys. I did remove the cables. Let me connect the cables again. To orange, green. Here, and this one must be moved a little down so you can see. Okay, go to the code part. Read digital pin 9 must be math. Go to high, and this one should be equal to, and this one is for 0.5 seconds. You can put 0.5. I would like to put 0.5. Okay, let us start and see if our pin is working. Perfect. If it is working, that means that we can repeat this. Instead of 9, now I'm going to go for 8. And instead of 60, I'm going to go for 58. I don't want all the pins to sound same. So let us start and see. Perfect. These two are working. I'm going to repeat this block. This is going to be 7. And I'm going to change the tone to 56. and 6 down to 54. So the first 4 pins should work. 9, 8, 7, 6. Let us see. 9, 8, 7, 6. Perfect. Now after 6 we have 5, 4, 3. Okay, we have only 2 pins. Duplicate. 5. Instead of 56, I'm gonna go 54. I'm just reducing by 2. Okay. Oh, 5 is done, so it must be 4. And finally we have one last block to be added. Duplicate, and then I'm gonna add the block. Instead of 4, I'm gonna put it as 3, and 54, this is going to be 52. Oh, let us do this as 52 and let us do this as 50. You can put any other things if you want to play around. You can change the tone value and see how it works. Once you start the simulation, these two sound the same because there is 2 times 54. So I'm gonna go to 52, 50, 48. Yeah, that makes sense. Start the simulation. You should be able to see. This is playing for 0.5 seconds. Let me change it to 0.2 seconds. I'm going to copy this and replace it everywhere. Maybe our sound is going to be more fine-tuned because there's a lot of decay on the sound. You can change it to 0.1 to make it more effective. But this is the code, okay? So I want you guys to see the code, but also this time I want you to notice the text. So the code is as simple as the blocks are very simple, but if you see the text, you see there's a lot of things. Okay, pin 2 is output, but pin 9, 8, 7, 6, 5, 4, 3 are input. That means you're reading the sign as an input. Whenever you're pushing the button, Arduino is reading it. Arduino is taking it as an input. Okay, so what I want you guys to do is I want you guys to again select the blocks part of it and take a screenshot of your name along with the circuit and along with the code. I need to see this in your documentation that we are going to prepare. And in the next video, I'm going to show you how you're going to make the documentation for chapter 2. But before that, I'll also make a video on completing chapter 1's documentation. So you need to complete chapter 1's documentation, turn it in, get graded on that, and then we will move to chapter 2's documentation. Okay, after 2.1 we still have 4 more projects to do, and they're also relatively very easy. In that we'll not be using these many components, like how many electrical components we have used here, a bunch of 8 or 9 resistors, a lot of cables, and we are not going to use those many. So the circuit looks very simple, but the coding or the blocks are going to get little tricky. But if you pay attention, nothing is tough. Okay, thank you guys. See you again on the next video.